other ladies and gentlemen, dear colleagues. Actually, the topic of this presentation is the spatial variation of irrigation water parameters around the new Jaya Ganga Trans-basin Canal of Thisa. Actually, this study was carried out by one of my students, Sapuni, since she is not available here. Let me make this presentation. We all know that the new Jaya Ganga is a kind of a trans-basin canal which delivers water from Canal to Thisa, which was constructed under Maharani Development Program about 50 years ago. It is parallel to the very ancient, remarkable irrigation canal. We all know that it is historic Yoda. The difference between this Jaya Ganga and Yoda is the Jaya Ganga, the body is somewhat higher. It has a very higher discharge rate because the Maharani water from Canal to Thisa. But the Yoda, you all know that it has a very shady floor, therefore the discharge rate is somewhat slow. There are some issues actually reported basically in relation to this Jaya Ganga because one is actually pollution, the sedimentation, the pollution mainly due to agricultural land uses, then the algal growth, especially the latter part of this Jaya Ganga and the downstream. But another serious issue is the streamline erosion, but because of the higher discharge rate, we all know that Jaya Ganga is not a complete line stream canal, it's a curving one. Therefore, the streamline erosion also there. For that, study was began to identify is there any pollution sources, point sources or non-point sources. Therefore, the objective was to assess the changes in water quality parameters with respect to suitability of irrigation. What is water? The Jaya Ganga Trans-basin canal with respect to the different land uses. Actually, this is the sampling point that we established along this canal from Canal to Thisa, and we can see different sampling points starting from the outskirts of the Canal, along the Jaya Ganga to represent different land uses, and then actually very close to the Thisa. Well, 10 sampling points were established to represent different land uses, and the coordinates of the all sampling points were recorded using a GPS receiver, and samples were collected from 2026, actually from May to September 2023, this 3-month period, with two weeks intervals, 50 to 30 centimeter depth. All samples were analyzed in our laboratory, Spatial academics. Let me directly move towards the standard analytical methods were used to analyze water parameters. Research and discussion. Let me share some of our findings actually. Now see the pH variation among 10 sampling points. Right? It varies from 7.3 to 7.7. It clearly indicates that the water is slightly alkaline in nature. There are two ways. There are two basic factors which affect on the pH. One is the land use, the other one is soil parameters. This may probably be the calcareous layer material on this bed of this canal. However, pH is well within the what we call this permissible range for the irrigation water. No more significant difference also, right? Even the electrical consumption is a very important parameter to be measured in irrigation water because it indicates the soluble salt. Again, no significant changes, difference was observed among sampling points. The easy range within the 0.16 to 0.27, then within the permissible range, but you can see the last three sampling points, 7, 8, 9 shows a little bit higher easy levels. The reason would be the total dissolved solid content. The last 7, 8, 9 sampling point shows it will be higher total dissolved solid. This may probably be the reason for the higher EC values. You know the EC is very important because once you this water flow towards the agricultural fields, the irrigable lands, the salinity would be developed so that the electrical conductivity value at the TDS of irrigation water is a very important parameter. Then one interesting finding, you see that nitrate nitrogen level, even though the nitrate nitrogen the levels within the permissible range of irrigation water, you can see the sampling point 2, 3 and 4 shows a little bit higher nitrate nitrogen levels. The same thing that we can observe even in the dissolved phosphorus content as actually there was a significant difference among sampling points as well. The dissolved phosphorus range vary from 0.07 to 4.5 and sampling points 2, 3 and 4. Basically 2 and 3 shows a little bit higher phosphorus content in irrigation water, mainly probably due to the land use. Because sampling point 2 and 3, which is close to the marine column area, where the surrounding land use is better. So it may probably be due to the surface runoff which comes along this pattern is the fertilizer runoff. And another is when it comes to the sodium absorption ratio, it is there within the permissible range less than 10. It clearly indicates that sodium is not a problem in this irrigation water. Therefore, there is no risk to develop sodium. I mean, sodium creates a lot of problems in agricultural land, but that risk is not there because it's there. Sodium absorption ratio is very within the permissible range. But see the derivatives. One is cadmium. See the sampling point 4 and 5 shows a little bit greater, higher cadmium content, even though the value of cadmium range is well within the less than permissible range. Sampling point 4 and 5 shows a little bit higher cadmium content in the irrigation water. The same thing we observe even in the arsenic as well. Okay, see 3, 4 and 5 shows the higher arsenic content compared to other sampling points. Actually, the reason would be this water flows along this power area. This is a kind of a earthen canal. It's not a complete line one. It moves towards this apatite deposit. The apatite mineral contains some heavy metals, very, very small quantities, very minute quantities. This may be the probable reason. Actually we need to investigate it a little further, but it may be the reason for the higher cadmium and arsenic levels that we observe when it flows towards sampling point 4 and 5. So with this actually we would like to conclude that the relative nitrate and phosphate recorded in sampling points, they are the main land use categories. Therefore, the one non-point source will be the agricultural land use, especially to fertilizer runoff. The other one is relatively higher concentration. I am always saying this relatively, which the concentrations are well within the permissible range. But if you compare the different sampling points, the cadmium and arsenic shows a little elevated levels when it flows towards the phosphate deposition properly. So finally, even though what is tested parameters were very within the irrigation water limits, permissible limits, we need a long-term monitoring process. If there are any risk to develop salinity in the irrigable land or the accumulation of heavy metals in the irrigable land, this irrigation land. So let me conclude my presentation. So thank you very much all for your kind attention. Even though study is not my one, any question is
Thank you very much, Professor Masweta, for your nice presentation.